Welcome everyone to the September 22nd OMR Architecture Meeting. Today we have one topic to discuss. So Gita Koblenz will be talking about some of the work that she's been doing recently with the vector and mask IL opcode changes. So I'll turn it over to Gita and please take us through it.
Thanks, Daryl. So title of today's presentation is Vector and Mask IL, and it will cover some implementation of some earlier proposals and also present new PRs, new proposals. So first I'll give some background, then we'll talk about implementation of previous proposals for vector types and opcodes, and then we'll talk about adding more recent work, adding mask types and opcodes, and then we'll summarize all of that together, vector and mask opcodes. So in terms of background, the motivation, of course, is to exploit SIMD capabilities on various platforms, and we would like to support vector operations for various vector lengths, like 64-bit, 128 to 56, 512, of course, and maybe even bigger, for different element types of those vector lengths, like all sort of scalar OMR types, starting from int A to double. Then we would like also support masked vector operations and operations on masks themselves, because you can have and or masks or all true, any true, and so on. I'll give more details in a bit. So in terms of what happened earlier, right, we presented a proposal on OMR Architecture Meeting last November, and proposed to expand TR data types enum to present all vector types. And the key, I think, was the key part was that we would like to generate those types at runtime, not list them, all combinations, which also possible, and some compilers do that, but more make them sort of hidden and generate them at runtime and encode those parameters like vector length and element type into sort of various designated bits of enum, of this enum, and then generate vector opcodes using some API, specify some sort of general vector operation, for example, v-add, and then also specify vector length and vector type, element type. And at that time we didn't discuss masks, so that will be new. So this is the background. Sorry. And as soon as we kind of more or less sort of agreed and discussed that proposal, we started implementing vector types. And the way we did it, and it was maybe early this year or spring maybe, first we added that vector length enum, it's here, right? So basically length is presented not in terms of bits, but in terms of enums, sort of discrete values, right? 128 to 56, 512, and then there is non-vector length supported. And since some platforms support only one vector length, you can make it platform specific just to save space. You can still have 512 for everybody, but to save space. So for example, for all other platforms, it's just only one vector length, 128. And for x86 is all this length supported. Oh, sorry, up to 512 supported right now. And we allocated space as we planned in data types, removed all old vector types and added basically and introduced num scalar types enum member, and then num vector element types, and then computed num vector types as a product of vector element types and vector length, and increased num all types by that value, num vector types. So essentially allocated space between scalar types and num all types for vector types that will be generated using APIs. And just for convenience, for different queries, we have like first vector type defined here and last vector type. And of course that API create vector type that takes element type and length, and it will return enum, like this enum that sort of will correspond to this combination, kind of encoded. But what was different from the proposal, we didn't use like bits. We just did like kind of like a flat matrix representation, very simple. Like first listing, for example, all like sorting them by length. I think we sorted by length, kind of like a flattened matrix, just using just basic arithmetic, no like not bits. It's more dense. It makes it more dense than using separate bits, and kind of cleaner, I think. So yeah, I mentioned that, and these PRs that were used to do this, they're merged. They've been merged. So these are essentially adding vector types. And then we move to adding vector opcodes. And in order to add vector opcodes, we introduce notion of vector operations. And which is very similar to opcode macros in a similar enum, but we created new file with enums and listed all like general vector operations. So instead of like opcode macro, we have vector operation macro, but all the fields are very similar because they will be used in all the same tables that opcode macros are used, being expanded. Yeah, so here I wanted to show that there are vector operations that return vector and sometimes returns a scalar. So for example, VAbs takes absolute value for each element and returns vector result and has only one child, right? And there's no type because it's some vector of certain type, so we cannot. It's like API will tell us which type is that. For specific opcode, right? For operation, we cannot put a type. So VAdd is very similar, just that it has similar properties as like scalar opcodes, but it returns, it also returns vector result, and but it has two children. And then we have vector, still like vector operation, but it see, it doesn't say vector result, which means it's scalar, like reduction returns scalar result. So these are more typical, but we have much more, of course, I will show all of them, but these are typical vector opcodes, and we use these 3 PRs to implement those. So any questions so far on vector types and vector opcodes? We can always go back to it. So this work done, then we moved, sorry, oh yeah, keep forgetting. Yeah, how we use this macro, right? So we listing here all vector operations by simply kind of, taking only operation from this macro. So this will be enum of all vector operations. And then and also I need to mention that there are opcodes that have only one type, like addition, right? It takes source and result are the same, but for example, conversion opcode has 2 types, like source and result. So we need to, and we kind of separate in this list. We have that macro that's saying which one is first 2-type vector operation. And given all these enums, we now can calculate how many vector opcodes we're going to have. So number of 1 vector type operations is it's this enum, this value, right? Then 2 type vector operations is all vector minus the one that have only 1 type. Anyways, it's number of all vector operations. And then we multiply number of the ones that have only 1 type by number of vector types, and the ones that have 2 types like multiplied twice, and this will give us all vector opcodes, right? All vector opcodes. And so instead of num all IL ops, which is like old enum, being just number of scalar opcodes, we add all these products, all these products for vector opcodes, which include like simple, like like add additions and like ones like conversions. So what is nice here, it's kind of all this type safety, right? Like, so now all these enums, all these generated enums will fit into this enum. We don't need to check like whether this value is big enough. All kind of type safety is preserved. And then of course we have this API, create vector opcode with one type and create vector opcode with two types. And what is important, right? We all these tables, right? Like all kind of properties. Now they don't have entries for all vector opcodes. They only have entries for vector operations. So we define that function get table index, which for scalar opcodes will be just that opcode itself, like usually how we dereference all the property tables. But for vector opcodes, it will return vector operation and will return sort of like correct index, like in all the tables. They will have all this as usual scalar opcodes and followed by entries for vector operations. So for example, like name, right? For if we have like say opcode, something like that, we add vector 128 in 32, it will return entry for we add. Because all of these opcodes essentially share the same properties. So that this type of that get table index sort of we use for accessing all the tables indexed by IL opcodes enum. So yeah, I sort of talked about all of that. So this are vector opcodes, and yeah, so and now we are moving to mask types. So all of this already done. Mask types, it's relatively new. And again, we start with adding types into data types, very similar to vector types. You see like those vector types, but we also add a number of mask types. It's the same as vector types because they always like sort of that one-to-one correspondence between them. I will talk about it in a second. And similarly, we have first mask and last mask, and now we added, we have a scalar types, vector types, and mask types. And also we can now create mask type, very similar to vector type, giving element and length. So it's important to have, even like say platform doesn't have special like mask registers. It's important to have mask type, I think, sort of logically, it kind of tells us that it will be operation on this type of mask will be, how to say, like it will operate on this type of vector length and this element type. And so even platform, for example, Power Z, that they don't have mask, special like mask registers, they will use mask types. But in addition, which a little bit slightly complicates things, even on, say, x86, where mask type, there are mask registers if with AVX512, but we know that only at runtime, right? So we'll have all these mask types, and we have like opcodes of mask type and so on. But only at runtime we're gonna know. We will use actually mask register, like AVX512 mask register, or regular vector register to represent mask. And representation will be different, and size will be different. So it's a little bit problem similar to modifying like address, size of address type. And I remember we used to, then we kind of improved it, but it was always considered sort of not a great thing. Like when we modify different like properties tables at compiling initialization time, so which is not like very nice. So at the same time, it's a bit, it's we need to think if we want to add compilation into get size. So what we did is to first time get size is called for mask type. Use this thread local value comp and query whether mask registers are supported or not. But it's done only once. That's expensive operation, but it's done only once using like local static initialization. So that because of that, we don't need to change that API, which is throughout, like it's everywhere. I think it would be hard to change. And I don't think it's very expensive because done only once. So that's how we solve that issue. And this is in that PR. So that's about types. Again, we can get to questions later. And then again, like similar to vectors, as soon as we have vector type, we can add vector, sorry, we have mask type, now we can add mask opcodes. But it's important to distinguish, right? There are masked opcodes and masked operations. For example, like add with mask, and there are operations on mask themselves. For example, is any value true in a mask? So this is this VM add, it's a masked operation, and it returns vector result, and it has 3 children. Third child is a of mask type. So basically, yeah, the opcode will look like this, and it will have 3 children. But many true is, you see, it doesn't have that property, vector mask, because it's not masked. It's just given one mask, it checks if any element is true and returns scalar value. It's like, it's like Boolean, essentially Boolean value, true or false. But then operation on mask can be masked itself. Like, for example, we can have any true. So when checking if any element is true, we will use mask and only apply that operation to elements that are enabled by a mask. So this operation has 1 child, and this have 2 children. Second one will be a mask. So this is vector masked, but still returns scalar result. And then also I sort of didn't have space. There are operations like load, which will have like mask result here, like because they return mask. So these new operations, and for mask and mask. Also wanted to mention that as I mentioned before, actually already, mask and vector types have one-to-one correspondence. That simplifies like internal sort of representation. We can use the same enums, like vector operations, the same file, because we never, for any given opcode, we don't have to worry whether it's like mask or vector. Sort of semantics of opcode will tell us, like the name enum itself will tell, like, oh, actually that value, right? Like mask will tell us it's masked or not, but it doesn't have to have like deal with yet another type. And we can use the same enums and kind of essentially treat mask operations the same way we treat vector operations. And but we know, like from that property, we'll know whether it's actually mask, returns mask or not. So it's a bit maybe complicated, but basically it simplifies implementations a little bit. The fact that this, we only, so if we have vectors say of this type, we're only going to use mask of this type and not any other mask for when when doing some masked operation on this type, only going to use this mask. Just simplifies implementation, I would say. And also need to mention that that mask type, what it actually means, it's internal. If some variable has that type, like mask type, it means internal mask representation. Like for example, on say power and z, it will be like a vector of like ones and zeros, like representing mask for each element. Like if some element of vector is considered like set by mask, it will have all ones in it and or all zeros. On AVX512, it's like it's 64-bit vector, just 1 bit per element. So different internal representation, but we assume that mask type, this type, it's an internal representation. And because of that, sometimes we need to convert to existing types. So because of that, we adding this new opcodes or operations, I would say operations, and corresponding opcodes like I to M, M to I, L to M, M to L, and so on, V to M, vector to mask, mask to vector, and so on. Because sometimes we need to convert like from existing like type OMR type to a mask representation. So this work, all of this what I talked about is done in these PRs, and this one already merged, and this is under review. And but there's still a bit of remaining work, like for example, those we already modified TRIL to recognize like vector opcodes, and it will, I think it will recognize mask opcodes automatically, but we didn't handle yet like those two types opcodes. Like they will look like this, right? For example, if it's conversion, it might be, for example, conversion of vector 128-bit vector of ints into 128-bit vector of floats. So kind of a long name, but that's what it is, right? Conversion has two types, source and target. And similar for this conversion, like V to M, for example, vector to mask. We might see such opcode. We already can see that in a trace file, but TRIL also has to recognize this. And we'll be adding more opcodes, I think, on demand. So now to maybe perhaps make it a little bit more clear, like here's a summary of all new vector and mask related opcodes, or I would say more like operations. And so there are one type non-masked, one type masked, and two type operations. So one type non-masked is like those regular, like add, and compares, loads, max, min, and so on. Then reduction, they return vectors. Then reductions return scalar. Then reg load, reg store. Yes, return. Return we already had before. The set elements plus basically names, I think, speak for themselves more or less. And then one type, yeah, and also one type include mask operations on masks, like menu true, loading mask, direct, loading mask, indirect, app store I. Of course, we need mreg load, mreg store, because we might use different registers for mask types, right? And those conversion opcodes that I mentioned. And then practically all of that, but masked version. Not all of them have masked version, but for example, still one type, but masked. Like for example, vapps and vm apps, like vadd corresponding vm add. So not all of them have masked versions, but the one that apply, we added here and here. And as I mentioned, can be a mask operation, like with a mask itself. So these are one type operations, and then two type is cast, conversion, and this vector to mask and mask to vector. So all of that been added. all these operations, and of course API out of these operations you create actual opcodes for specific vector lengths and specific vector element. So that's, I think, all for now. Like, and please, any questions are welcome.
Sorry, maybe I missed this, but when you were talking about the 1:1 correspondence between mask
Between mask and vectors, this one.
yeah, so I wasn't clear on why that was required. Like, what? Maybe an example would help me at least get on the same. Like,
Yeah.
what would go wrong if I just had mask 128, for example?
We could, but that's true. That's true. We could, but I think sort of that's why did we decide? It's a good question. Why mask in 32? To be honest, it sort of was prompted by Vector API library, which most of that work actually was prompted by Vector API library in Java, and it has that correspondence. It's true that strictly speaking, you don't need element type, but yeah, it's a good. I'm trying to remember why we decided to add element type. It's sort of I think we could have had just mask one. No, I'm sorry. We have to know, right? No, 128 would not be enough, right? Because we need to know that there are 4 elements. Like the mask is per element, right? So it's true or false per element. So this one has 4 elements. And this mask also has 4 elements. So for simplicity, it's like much easier, instead of saying like mask of 4, right? Just to have like full vector type. It's just, I think, simpler to do it that way. So yeah, 128 would not be enough. We need to know how many elements.
Okay, but that does open the door to having a different, like just specify the number of elements then, like
Different type.
yeah, just have a type for mask 4 if it has 4 elements. Could we do that? You said something about simplicity. Maybe I missed that.
To be honest, like the kind of like, because mostly is because in that let me think again. Yeah, strictly speaking, I think we just discussed it and decided to do it that way. Sort of to make them similar to, like, it kind of tells you on which vector you. I would say you're right. It's a little bit redundant right now, but provides additional information on which vector it is working on, to which vector that mask is applied. So kind of, yeah, we don't know operation yet where we need to know actual type, element type, but so there's some element of redundancy, but I think you definitely want to know, vector length. Like, for example, on power Z, its mask is represented using vector registers, and we need to know the length. We don't have example yet where we need to know element type, but kind of for completeness, added type, and so for uniformity, kind of like with vector types. But
Okay,
it's I would say currently it's redundant, but yeah.
Yeah, no, that's fine. I mean, I'm trying to absorb the design myself, so I'm not objecting or anything as such. I'm just getting oriented myself. Thanks.
Yeah.
I'm in a similar state, but also have a question on a different part. I was gonna ask about the choice to use to kind of define what a mask type is based on what the hardware has available to it and kind of emulating what we do with address. I wondered if you also considered and rejected kind of the same approach that you do with vector length, right? Like, so having different mask types, but you don't necessarily have all of those different types present in the set of data types in the run. So you'd have like a mask type for like a bit field mask and a bit type for a byte array mask. And then I know you'd end up with more opcodes, I guess, because then every opcode would have to have a bit field and a byte array variant, but you'd only need to define one of those sets in a run, if you know what I mean.
Yeah. I basically have two mask types, right?
Right. Yeah.
Yeah.
Which would then sort of be possibly a nicer way to handle it if a third type ever kind of materialized for some other platform. Right now, I assume all of the vector masked opcodes have to have a conditional in them somewhere to say, am I this kind of mask or that kind of mask?
I think definitely considered, definitely thought about it, but I think the issue was with unfortunately I didn't show it here, but here, like for example, if it was like mload, we need to put a type that it's a mask, right? So, and we don't know, that table contains type. And we don't want to modify, like we need to put something here that it's like similar to, for example, here we have vector,
Right, but
vector result.
but in that case, you'd have two types of M load, like an M1 load and an M2 load. Now you call them something different.
Got it. Yeah. I guess that's what kind of I felt like maybe it would be too many. Yeah. Then, yeah, then, but I guess try to maybe wrongly or not, I don't know, but sort of didn't want to, I guess, to expand number of operations for every internal representation, because there can be many representations, right? Like so to have, yeah, I guess try to avoid operation for every internal mask representation, I would say, yeah. But I see what I mean.
So you'd only have to define one of those sets in a given run, right? The same way you don't necessarily define all of the vector lengths in a run.
No, these are different. You see, operations are all defined statically. All of that are statically. Their size and element type are like determined at runtime, and can have various. At the same run, you can have VM add of different lengths and different elements, but these operations are in a static array, similar to opcodes. And so, for example, if it was address, like AL add, whatever, like regular address opcode, we would modify its size somewhere here. But then I think we improved it.
Sorry, but I thought vector add you'd have a vector add that was specific for each vector length, don't you? Or no?
Vector.
It's just a basic vector add.
It's basic vector add. Like let's maybe go back to non-mask, right? We have basic what we call operation. It's kind of general opcode, kind of general operation add, and then we have this create vector opcode given operation and vector type. So we allocated space for all these opcodes. You see now IL types, but we only create them at runtime. But we don't need to know like we don't need like compilation for that. We don't need to ask, oh, what kind of support that hardware has. For mask, we need to have a compilation object at hand to say what size it is and what kind of mask we need to create. So it's a bit different. Yeah, I think I see what you mean. Like vector types has variable, all this opco like operations, they have variable length and element type, but we know it after we created it using this opcode. All this we have queries on this opcode. We can, anyways, we sort of, when we create IL, we know what length and what element type we want to create. But and similar to masks, but with masks, like logically we know with the same thing. We know logically with vector mask, but we don't know how it will be represented.
But that's going to be, isn't that going to be target platform specific too? Like can a single, like can x86 have both types of mask types defined?
Only one at a time, and when we first time ask for its size, we're gonna ask compilation like that.
Right, that's my point, right? That isn't that really just an x86 or a power or a 390 answer that you're going to get? I.e., it could also be determined by tera target.
For power and z, we know at build time that function get size will return like 16. It's hard-coded for power and z. And for Intel, since we don't know whether we have AVX support or not, at runtime will determine. So for power and z, it's a fixed size. Mask is fixed size.
For x86, it is really a dynamic question whether which type of mask register will get used.
Because there is only one, like there is no really mask register, there will be vector register. But logically, we'll use like masked opcodes and mask type. Because I think it's nice to have IL, the same kind of consistent, you know, and mask operations will have mask type, even though underneath it actually will be vector register. And we know its length, and so we'll return 16 for get size. But will look like mask. We'll still, even on power and z, we're gonna have like VM add and the mask. Third child will be of mask type, but a little bit more complicated, yeah, on Intel because it's not. We don't know at build time, right? When we build JIT, we don't know how we're gonna represent mask.
So on x86, if I'm looking at a log, when do I guess it's only when instruction selection is happening that I actually find out what type is being used for mask?
What vector we're going to use for mask will be only known at code gen time, yeah. Yeah. So for example, yeah, like Jerry, right? Like for example, I added mreg load, mreg load, mreg store. Everybody gonna use, all platforms will be using mreg load, mreg store, but Intel will use, depending on AVX support, will do whatever is needed here, and power and z, for example, will use will map it into will use vector register, so will behave as this ones. We considered other options. Yeah, I think we sort of considered like what you suggested, but decided to keep it kind of reduced. Yeah, sort of keep like IL kind of on a logical level, like, and actual representation on a cogent level.
So to be clear, I'm not suggesting anything. I'm just asking if you consider an alternative. What the response were.
Yeah, I understand. Yeah. We can see. I think we thought about different things.
Yeah. Thanks.
Any other
So
questions?
this isn't about mask, but I'm just curious what or unchecked means.
I expected that question. Yeah, again, that was prompted by Vector API library in Java, and they use such opcode, and it's actually or for float and double. I think it's some kind of like, not sure exactly, but I sort of added it for completeness here. Yeah, there is such operation like OR for float and double. But if we find it's not needed, like we'll remove it. But for now, I sort of wanted to not to forget about it, like added it.
So that's a bitwise OR?
I think so, but to be completely honest, I'm still not 100% sure. Like, I think it's just bitwise OR, yeah. But there is such operation in the library, so I added it for now. But sort of a bit of a to-do. I think I should add it as a to-do to have a better understanding, I think it's just bitwise.
Okay, thanks.
Yeah, sorry, yeah. I don't know. Others, I think, pretty sort of explanatory.
Do you have a question?
Yeah, hi.
Hi.
I think, thank you for the presentation. And I have just a question. Do you have any guidelines or maybe patch notes, how to update, how the projects that consume OMR should adapt to using the code you introduced? Because I think there's a discussion in some issues, I think 67 or 09 specifically, that the introduction of these types results in some sort of breaking compatibility, maybe.
Yeah, very good point. I think in this one, I kind of try to describe all steps that need to be taken in the first one, in the very first one. It's basically the intention was to change all the names, anything that could cause functional problem, sort of. I change the names so that it will break the build and bring the attention to the attention that something needs to be changed, because you're right, like basically we had like old vector opcodes somewhere here. We moved them down. I think they were before like aggregate maybe. So order has changed, number of types have changed, and so some tables that indexed by this enum need to be adjusted. And I think, oh, sorry, this first PR, I think here I described that. But so,
Okay.
yeah.
Thanks. I'll look into that.
Yeah. But please let me know if you have any questions.
Sure. I will contact you after regarding like the specific issue I'm having. Essentially, for some reason, my compiler started generating mask types on something that was working before August.
Interesting.
Yeah. Okay.
Oh,
thanks.
Yeah. Please let me know. Yeah.
To follow up on Georgi's point, I think the issue he was referring to that I was one that I had introduced to OMR on a similar issue, and I think it's not a direct result of the vector and the mask work exactly. It's more that the vector and the mask work expose a sort of fragility in some of the places that the data types enum is being used. At least that's the way it came off. That was the symptom in our case, where we also began hitting this assert on a mask data type, but it's only as we're walking through the enum, right? So there's one place in the I think only one place in the compiler where we start when we're looking for a conversion between types. So there's this decode conversion opcode function, and it tries to walk through the enum of data types one by one and find a conversion. And if you don't, if you're a project a downstream project that doesn't have any additional data types, you can choke on this this loop basically in decode conversion opcode.
Decode conversion. Trying to remember where is it? Decode
Yeah,
conversion.
this is in OMR. It's in what is this? Simplifier handlers.
Yeah.
Simplifier helpers, I should say.
Mm. Yeah, maybe like open an issue. Like it's about, probably started happening with this more recent. This one probably. This was adding. No, sorry, keep forgetting this one. Mask types probably since this one.
Yeah, I think that was
Yeah.
yeah. So there was a kind of an issue with this that we introduced a kind of a workaround inside of that loop. This is separate. That was separate from the vector and mask work. That wasn't part of the problem in that case. But then you're right. Once the mask types were introduced, then we sort of began to hit the same problem again for a different reason, right?
Oh, yeah. Please let me know. Yeah, it's possible, but
Yeah. So there's an issue. In fact, I think Daryl just
there is an
posted
issue.
that there.
Okay,
yeah. So if people want to refer to that where I sort of spelled it out in more detail, it's easier to read it probably. Have a chance.
Okay, so it's in the chat. You posted it in the chat.
Yes, in the chat window there, Daryl already mentioned 6709.
6709. Okay, I'll take a look. Yeah, definitely.
Yeah, cool. Thanks.
Yeah, thanks for letting know. Yeah. So, any other questions? So yeah, like vector types been there for a while, and I don't think they caused any major problems. Although I think you mentioned there was something, but masks are relatively new. We'll see. Like we're sort of still kind of, I would say, experimenting with that, with those, especially those conversions are kind of interesting, right? And we're only starting like prototyping, like CodeGen and OpenG9 for those. All right, I guess, yeah. Maybe I'll give.
Sorry, Kevin, I didn't see Sandhya's comments that she added last week into the agenda about wanting to discuss that issue 6709. Is that something that you want to bring up now? And you think you have the right audience to discuss that too here?
Yeah, sure. I mean, I can give a little bit more detail, and that way we can, if folks have feedback about how you want to go about it, because there's basically, yeah, I can do that. Sure. Thanks.
Sure. Agita, are you finished? Or,
Yeah, I think if there's no other questions, yeah, please share your screen. I think would be helpful.
My screen here. Okay, can you all see that?
Yep.
Okay. Yeah, so the issue that we ran, there's kind of two issues. The first of which was we had this kind of workaround added. So the first issue was that in this, so here's this function decode conversion opcode. It's one of the simplifier helpers. And you can see actually here that in the comment it sort of notes that this is only meant to be used with this conversion map table, which seems to be the case. That seems to be how it is used. That table is here in OMR IL apps. And you can see that this basically covers like the what we would now call the scalar types, right? And in any case, what we end up doing here is in this this loop, right? We're walking through each of the values in the data types enum. Probably this value is no longer the right one. So part of the it's to me a little bit of an open question how we want to specify this. I was thinking, I mean, one way of changing this would be to say that we turn this into scalar types instead of number of all types. I don't know if that's accurate for in all cases though, so that's something that folks would have to weigh in on. Because if this is only meant to talk about the types that are dealt with in the conversion map table, right? We don't want this to walk through the vector and the mask types, for example, right? So that's sort of the most recent issue is this. We started hitting here when we get into get proper conversion. At a certain point, this the I has incremented past the types that are relevant, right? In this function, and we go try to take that I and think of it as a source data type and go to get proper conversion. And when we do that, we're going to turn around and pass it again to get data type conversion. And what that looks like here is, so there's handling, right, in get data type conversion, presumably for the case of other callers to this function. For the vectors, so we're kind of okay with the vector types here. But if you don't have a some other override of this function or whatever, you're gonna hit this assert, right, as soon as you get past the number of OMR types, which is to say basically past the scalar types. So most recently, when the mask types were introduced, this is where we started hitting this assert. Prior to that, we were hitting this assert for a different reason, which was that if you don't have a project-specific definition of additional data types in this data types in a project level data types enum.hpp, you would actually also hit that assert when you are again walking through the enum of data types. You get to number of OMR types, and it will the same thing would happen, right? So that was actually how this came to this piece of code here came to be, where it's kind of basically a workaround, right, for the fact that number of OMR types is not a valid source data type. I don't actually know if this. I sort of began to wonder if this is actually even correct for other projects that do define project-specific data types. That's another question that other folks would have to weigh in on. If this is okay and doesn't have any issues for projects that do define their additional data types beyond those that are provided in OMR, then making this number of all types making this just be, for example, the scalar types might be all that's needed to be kind of fix this this one kind of strange case, right, where we're walking through all of the data types in the enum. But that's basically what I wanted to sort of present to folks to think about with us as we sort of try to come up with a solution to that.
I'm just curious, do you know if it's like recent code, that loop? Because I think when we were adding all this, expanding num all types, I sort of grabbed for all of the occurrences, and I don't remember this one.
This one, I think it's been around for a while. I don't think it's
yeah.
That's interesting. Yeah, so maybe something was missed here.
Because here we want to say the situation is for downstream projects, not every project has its own extended data types. Like for OpenGNI, we know, yes, there's plenty of extended data types. But for our own project, we don't have any additional data types. That means inside the data type header, the ending data type would be like OMR types. Following that would be a dummy header for the downstream project to add their extended data types. And again, ending that header, there's another name them scalar type or something like that. So there's a gap here. If for the case the project has its own extended data types, seems like not an issue. But for projects without their own extended data types, then that's an issue.
Yeah, I mean, I think that one of the things that this is shining a light on is we need to make sure that we understand what some of these special enum values are really meaning, and the code that's using. So, for example, decode conversion opcode. What exactly is decode conversion opcode supposed to be doing? Should it be considering the vector types? Should it only be considering vector types? Should it only care about the OMR primitive types? That sort of thing. And to be honest with you, I think that what we have to do is to consider these pieces of code to try and put the right semantics around them so that the code can be written properly. That's one thing. The other thing is to make sure that the enum values themselves make sense, and people understand that when they use something like num all types, they know exactly what it is that they're getting. So I think in this particular case, just looking at decode conversion opcode, there are conversion opcodes for vector, there's conversion opcodes Gita just talked about for the masking vector opcodes as well.
Yeah.
One might realize that these should be part of this loop as well. And obviously they may be getting excluded from that. And that might mean that the table that's being consulted here needs to be expanded as well to capture those new vector conversion opcodes.
Right.
So
It seems weird that num OMR types is being specifically excluded, like not looked at all.
You know what that is? That's actually, it's taking there's a placeholder in the enumeration for num OMR types, I believe, and it's skipping over that.
Right.
Oh,
it's its own value in the table, which is.
Yeah, I see.
Yeah,
a downstream project would define its first scalar or its first extension type as num OMR types, but if there isn't one, then num OMR types is okay. So, but that, as you say, that's probably wrong in the case of somebody actually defining additional types.
Right.
Yeah,
it's like num scalar types. You're trying to iterate to, in a way.
Yeah.
But skipping num OMR types.
Yeah. And I wonder even if, I mean, one thing that came to mind was that if you, in the OMR project, so this data type's enum is blank, it's just kind of a dummy in the OMR project, but if you just defined number of num OMR types, well, I guess you couldn't call it just aggregate because then you'd be off. Actually, that wouldn't be true.
Maybe we can just inside that dummy header file define the OMR types equal to scalar types maybe, and for the downstream project they can free to extend on their own.
Yeah, I don't know. Anyway, that's why I wanted to discuss it, because it's not a totally straightforward solution.
Yeah, I mean, thanks for raising this, Kevin. I think that there is something here that we need to clarify for sure. Are there other places that you're aware of that you've encountered that we might need to consider as well?
I believe this is the only one of this type, of this kind that I've seen anyway. Of course, it's possible that there are others that I haven't encountered, but this is the only place where this is kind of seems to be kind of this persistently kind of data types being prone to break.
Okay.
Yeah, and I will note, by the way, just to throw this out there as well, that this decode conversion opcode, because I had the same thought that you mentioned about the fact that there are conversions between vectors and masks and the other types, not just the scalar types, right? At the moment, at least, this function, this helper, is only getting used in the int demote simplifier, I think. Yeah, two places there inside of the int demote simplifier, which is itself if I remember correctly, that itself is a helper to the yeah, to some of these integer type simplifiers. Let's see. Right.
Being called on vector conversion opcodes is weird.
Right. Yeah. At this point, at least, it doesn't appear to be sort of suited for that use. Although you may want to leave the door open to be able to use it in that context potentially in the future. So I could see that too.
Right. I mean, again, it's partly a documentation responsibility here to make sure that the naming of the function and its operation are clearly described.
Yeah.
Okay. So I'm trying to think if we should address this as part of some of the vector work that's already ongoing, because it seems to have introduced this problem now, or if this is something that we should just consider separately altogether and let's say use the issue that you've already created to come up with a solution for this.
Sure.
Maybe the second one.
Yeah, and what I was going to say related to that too is, I mean, the part of the problem was reintroduced with the work on the when the mask types, were introduced, but this issue with the number of OMR types pre-exists, predates the anything to do with the vectors, right? We started hitting this simply because we started using these data types files, basically.
Right.
Yeah.
Yeah, I'm trying to remember that number of OMR types existed before vector work, or it was.
It did, yeah.
Oh, okay, so it's not me who added that. Okay.
No.
Okay, thanks. Yeah, we maybe need to think like it has to be sort of, there should not like special types like that.
I mean, it's almost like the num scalar types things needs to be a little bit more intelligent about whether num OMR types is the same as whether user types were added.
Yeah, it's kind of similar issue, yeah.
That's tricky to do.
Yeah, I wonder why we have it as an enum even. It could be just some static final in that class.
Yeah, true. I know that with like the IL opcodes, enum kind of, instead of having some of these like number of OMR, in that case opcodes, or IL ops, I believe the way it's done there is to say, first OMR op equals, no type or whatever, last OMR type equals aggregate, and then if you want to know the number of them, you can kind of calculate it, right?
Yeah.
Mm-hmm. Yeah.
Another possibility.
But I think it's important to have this one, like num all types, like defined here, because then it's sort of like, it kind of like defines the scope of that enum, the size of the enum.
Yeah, sure.
But the intermediate ones, yeah, the ones that are not needed for these calculations of vector types, they can be just separate, like static final variable.
Yeah. So that's definitely a possibility.
I think you're right, Kevin. I think if you were to change this to use the first OMR type, last OMR type model, then you might be able to properly set what num scalar type should be.
Mm-hmm.
Although you might need to introduce a first and last downstream. That might be harder. Yeah, maybe I'm wrong.
Yeah, right. That's true. Right.
Tricky. You don't know how many downstream projects could be in principle. It could be more than one downstream project.
Right.
Be in trouble.
Yeah. I don't know. I mean, I don't know if the presence of, if sort of doing a little bit of both is too complicated, but I don't know if the number of scalar types itself presents any issues elsewhere. I guess it leaves us in the same position, so that later on it might, but at the moment I don't know that it does. Such that we could still have this be an enum value the way it is now, and sort of
Actually,
but it
is
doesn't
anything
have to
actually
be.
using num scalar types right now?
What's that?
Is anything actually using num scalar types right now?
Right, I suspect probably not really.
First vector type uses it. That's why. Yeah.
Right.
It's used to compute all the types.
Right. So it's used within the enum, but I don't.
Like the way that we've worked around that in other enumerations, in order to count the number of downstream contributions or even architecture contributions to an enum, we'd have something, let's say in this particular one, you'd have at the beginning of the enum, you'd have like first scalar type in this enum, and then you'd have all the OMR ones, and then you'd have your pound include, like you have it here, and then the next one after that would be last scalar type, and then num scalar types is defined as last minus first plus 1.
Right. Yeah.
So there are more tricks you can do with enums. It gets a little bit ugly, but it's certainly doable.
I think most of that craziness would need to be in, it would only need to be in the OMR enum, right? Like it wouldn't be passed on, like you'd have downstream enums, just adding more things into the enum, and all the complexity of figuring out what the right boundary values are would be in here.
Yep.
I think so, yeah.
It would be contained and not passed along.
Right.
So can I say that there are two issues, right? Like one is cleaning up this enum, and another one supporting like mask type by downstream projects. But I think if project knows that it has mask type, I think it should handle it right everywhere.
Yeah. Yeah. Sorry, go ahead.
May I comment on that my project does not use mask type, and I would rather not see this segfault because I really don't know what mask types even are. So it's just maybe fixing that loop.
Yeah, what I was going to say is I think actually cleaning up the enum, and then we will have to consider somehow how we, what we want the scope of this function really to be, and so on. This needs to be addressed somehow. But if we have the loop, rather the enum, sort of cleaned up so that we can properly say, then we can specify what I mean to say is if we have cleaned up the data types enum, then we can specify exactly what we mean in here, such that we're not walking over the edge into the types that we don't want here, I guess. Right. So it is two issues, but they're related to one another.
Yeah, and even making num OMR types, I don't even know if that's something it needs to stand on its own. Like, it actually gets its own element in that enumeration, which I'm not sure if it should.
Yeah.
Then you don't have to skip over it then.
Right, exactly. Yeah.
Because you have to know that it's there, because then you'd have to know that it's there to step over it. And if someone else is writing new code that doesn't know that it's a value that needs to be treated specially, then bad things can happen.
Yeah, I think the preference needs to be that there are no placeholder types in the enum if we can possibly avoid it. Like that should be.
Yeah.
It's kind of a problem. Kevin, it creates this special thing that you have to deal with everywhere, as you say.
Kevin, are you willing to take a shot at cleaning this up?
Sure. Yeah, I can do that.
Okay. Terrific. Thanks. Appreciate that.
Yeah. And Geeta, I may enlist your help somewhere along it related to the mask and scalar stuff.
Absolutely, yeah, absolutely. Yeah, I'm thinking about it. Like I think that Georgia maybe mentioned that, say, if you don't have mask type at all, like how to will have vector types.
Yeah, but I'll give this a shot.
They sort of come together. Like say some project doesn't have, if it has vector types, then it's probably gonna have mask type as well. But if it doesn't have either, that vector length enum that I showed, maybe it can be like 0, and it's all gonna happen automatically. Basically, there will be 0 vector types and 0 mask types.
Right.
Yeah.
This is also eventually leading into a discussion that I wanted to have at some point as part of this architecture meeting, not today, but a discussion around how we can better test downstream projects that are consuming OMR so that these kinds of breakages can be discovered sooner, or we have immediate feedback that there is going to be a problem downstream that we need to fix in OMR. I think that OpenJ9 is the biggest consumer at the moment, and it gets a lot of testing, but there clearly are up and coming projects that we need to make sure that they don't break. And I'm not sure if OMR releases are the only way to work around that, but hopefully with a bit of discussion we can come up with some ideas and some solutions that'll be satisfactory for downstream projects. So I'll work one of those onto the agenda in the coming weeks.
Yeah, so it's not, I mean, it's not a complete answer to your question, but I guess one interesting question is why didn't the JIT builder testing or even the compiler testing, which defines a compiler, a downstream compiler, why didn't those ones find this problem? Because they don't define their own types either.
Kevin, did you see this as a functional runtime problem, or did it crash or build, or not even build?
It did crash, yeah.
Okay, so Georgi, you had a seg fault, you said.
It was not a seg fault. It was an assert thrown by IL optimizer, I think, or something. It was essentially saying that mask 8128 type that I was not using is outside of bad. It was marked as bad IL operation.
Okay, I'm just wondering if the answer to Mark's question is that it's because whatever that optimization was that's consuming this is not being run as part of JIT Builder.
But it's simplifier. It's simplifier. It runs all the time during JIT Builder.
My sequence of IL operations that triggered that was unsigned conversion of int8 type into int32 type into int64 type, somewhere there. I don't have exact, like I cannot point it exactly down, but it was as simple. There was like one opcode that translated into 3 leaves of IL builder.
Right. Yeah, that was the other point, that Georgi's downstream project is using JIT Builder as well. So, but he's consuming it in a way we didn't anticipate. Well, we've been having discussions about that in we've had some discussions about that in another issue. We don't really have a clear set of directions on how downstream components are supposed to use CMake with something like JIT Builder.
Right.
If you want to include the building of OMR in your project, like if you want to build your project as part, if you want to integrate the CMake files from OMR into the consuming project, then it's not, we don't have clear directions on how to do that. And in such a way that all of the various environment variables that we care about get set appropriately. And so we end up with some kind of weird configuration settings that can cause some of those problems.
The closest I've got was linking my libraries into JIT Builder library to also support the iPath. Or, yeah, but I can share that if anyone is interested. later.
Are you making changes to JIT Builder itself, Georgi?
I'm trying to keep it as intact as possible. I have 2 to 3 calls to JIT that I introduced to the API, but I'm trying to do it as a downstream project that by linking way, I'm actually modifying the JIT Builder target, but through CMake system, not by adding files to OMR.
Yeah, yeah. So I mean, the typical way that I use it is to I build the JIT Builder library using CMake, and then I build something else using that just loads the library and uses it. So that's
I'm using.
Yeah, no, I get it. That's why the model that you're using is not the anticipated model. Let's put it that way. So we have to figure that out, I think, too, and that might be also playing into the problem that you're seeing with the masked opcodes.
One thing I was going to ask about the to your question, Mark, about the JIT Builder testing. Is there any? I haven't looked, so I don't know. But is there a does JIT Builder have its own version of get data type conversion by any chance?
I believe so.
That I know the reason I mentioned that is because I did look at J9 just out of curiosity, because when I encountered the problem I was like, surely someone has either encountered this or not encountered it for some reason. And what I found is that they have a get data type conversion that has an assert that isn't for the number of OMR types, so you wouldn't actually encounter the assert the same way.
Yeah, so JIT Builder doesn't have its own IL directory, so
yeah. So I guess not. Yeah,
pretty much absorbing everything from OMR directly. So,
okay. Well, I mean, we can do a bit of investigation, Mark, into what the behavior is of building JIT Builder as part of our PR testing, or our CI testing, to see why this particular problem didn't manifest itself there. Might give us a bit more insight as to what we can do to better test this.
But I certainly agree that the work to clean up the enum is warranted. I think that's an excellent first step, regardless.
Okay.
So thanks, Kevin, for offering to start that off.
sure, of course. Thank you guys for that discussion. Appreciate it.
All right. Any more discussion on this point, or any further questions for Gita? Okay. If not, thank you, Gita, for taking us through that, and thank you, Kevin, for talking us through that problem. Our next architecture meeting will be in 2 weeks. So thank you, everyone, for attending. We'll adjourn now. Thank you.
Thank you. Bye.
Bye.